Hello everyone, this is a video on functional interfaces and Lambda expressions in Java. So we'll be going over as to what functional interfaces are, why exactly the need for Lambda expressions in Java came, and how they help us. And after we are done with that, we'll be looking into what some functional interfaces that Java provides us. Examples for those may be predicate, supplier, consumer, etc. And then we'll wind up the video with a quick introduction to variable scoping with Lambda expressions. Right? So without any further ado, let's quickly start with the task one around as to what exactly are functional interfaces in Java. So, till now, whenever we have worked with interfaces, we just define certain methods there, and we have corresponding classes that implement those interfaces and provide the implementation for the methods that we provided in the interface, right? So, functional interfaces are a new concept. It just tells that the underlying uh, interface, if it is a functional interface, will just have one method, right? And only that method will need to be implemented. It can have other methods like static methods or default methods, but we'll go around as to what static and default methods are. But the abstract method would only be one with functional interfaces. So let's not waste much of time in theory, and we'll learn that while we see it in the video, right? So okay, let's create a Java package understanding functional interfaces, right? So okay, now let's create a interface. Okay, so for example, let's name the interface as example, right? So this is an example interface. Now if we mark it as a functional interface, now let's go to its definition. What exactly it is, let's better look at the Java docs first. So the functional interface annotation is nothing but it is used to indicate that this particular interface that we have defined is a functional interface. So that's a quick annotation that's provided by Java. You need not necessarily put this annotation, but it's if you put it, it will make sure that there are no more than one abstract methods, and obviously the code readability is also improved, which justifies the purpose that it is a functional interface, right? So for example, we have a method and we have this method like perform task, right? Now suppose if I try having one extra abstract method like this, what happens? It says multiple non-overriding abstract methods found in this. If I remove this, the functional interface looks good. So now I understand that so now I believe that you understand the importance of the functional interface annotation and how it makes sure that the code doesn't break for certain interfaces that are meant to have just one abstract methods. You can have default and static methods all you want, but the abstract method will just always be one. So that is in a nutshell about functional interfaces. Now, Java itself provides a lot of functional interfaces in itself. For example, let's look at this. So this is a functional interface in Java that is provided by Java. It has just one abstract method called test, and it has some default and static methods that are used for chaining operations. Now, you might have a question around what is the use of this predicate. We also have a functional interface called consumer, then we have a functional interface called supplier. So what exactly are they and how do they help, right? So if you have this question, then please watch the video. Yeah, so these have various methods like void except here, then a get here, and then in this function we have the apply method and so on. Now, each of these particular, so whenever you're implementing this interface, you have to, what do you call it? You have to implement this particular method, right? Now, so Java provides some standard interfaces that you can use. For example, if you're using a filter and you want to specify a method, so instead of putting all the definition here, you can use a predicate and then just specify the predicate name. So because you have the test method, and you can return a true or false indicating whether you want that particular element or you're filtering it out or you want it in, right? So these are some of, we'll go through this in depth as to how they help us, but I just wanted to give an example around what will kind of functional interfaces we have in Java that is given by Java. So again, there are a lot of functional interfaces that arise from the ones that we discussed. For example, there is this thing called as by predicate. It has two basically two arguments or parameters you can send, and so on. So yeah, this is it. Now I hope that our task one around what are functional interfaces is kind of clear to you. If you have any questions, please put it down in the comment sections and I'll be happy to answer. Now let's understand what default and static methods are. Yeah, as this video is more focused around Lambda expressions, I would not be going too much into depth around what exactly default and static methods, I would not be coding it, but I'll give you an example around as to how they help, right? So for example, you have a functional interface, later some requirement comes, and you have any kind of interface for that matter, later some requirements come and you have to add a method to the interface, but now that particular method applies to just certain classes and not all the classes need to have the implementation, or there is some common implementation for n-1 classes, and for one of the class there is one custom implementation. How do you deal with that? If you add a method here, for example, even if this is not a functional interface, let's remove it. If you add a method here called void perform task 2, now it becomes your duty to implement this method in all of the classes that implement this interface. But isn't that a problem, right? That is a problem, right? Because for the huge applications, there might be a lot of classes that are implementing a particular interface. If you go around changing code for each of the classes and then changing tests for each of the classes, it's a problem, right? So that's where default methods come into picture. So with default methods, you can provide the implementation here itself, and if needed, you can override the implementation in the corresponding classes. For example, we have this perform task 2 and this, so we can do okay, so let's return a boolean from here, and we can, if say, okay, based on any condition, let's not talk about what the condition is, we can return true, else we can return false, right? So now this condition we can talk about it later, but the important part is that if you have it as a default method here, you need not implement this particular method in all of the classes, and when this particular method is called on an object of the class, then the default implementation kicks in. Now, important part, you might have a question around what if, because Java supports, you can implement from multiple interfaces. So for example, if to just give you an intro, it is pretty much possible in Java to do this. Public class, for example, say school implements example, and then say another thing like supplier, some other interface, and so on. So this is pretty much possible in Java. Now, what if we have two interfaces? This is example, and say we have this thing called as example 1, and both have the same method name, perform task 2 and perform task 2 here itself. Now what do you do? Now if you create a class, for example public class school, that will implement example 1 and it will implement example 2. Now, okay, this should be example 2. Okay, no, this is fine as example 1 and this is fine as example. Now what should you do? Now the important part is that you necessarily need to override this method because it's a problem. Java doesn't know. So, okay, for example, if I implement these methods, you can see like in this case you're calling because you're calling for example 1. You can do this. Yeah, like you're overriding this method specifically and then calling the one that is provided by interface 1. So this thing is there that you need to provide the implementation because Java will not know by default which method to call from which interface, right? So that is there, first of all, to make things clear. I hope the use of default methods is clear now. Coming on to static methods. Now, static methods actually, it's nothing sort of genius. You can have static methods. I can have static boolean, some task, and you can have the implementation here. Then the problem of overriding it in the classes doesn't come here because you'll always be calling it on the interface. So logically how you'll be calling it is, so if you have this public class school implements example and example 1, then you will be calling it like this. Okay, let's say we have main example dot some task, right? So this is not a problem at all. Even if this has it, you will always be calling it example dot some task or example 1 dot some task. So I hope with that in context, we are pretty clear around what is a default method and what are static methods in interfaces, right? If you have any questions, please feel free to post it down in the comment sections and I'll be happy to answer. Now, before we jump into what Lambda functions are, how do they help, let's see as to how we used to solve certain problems before Lambda functions were a thing, right? So, okay, we don't need this example interface for now. So let's go ahead and delete that. Now, let's take a very simple example, right? So before we go to the code, let's look at it. For example, you have a list of products, right? So you are an e-commerce company and you have a list of products and you need to sort the products by price, right? Sort by price. Now, again, I want to keep certain things in context. There might be multiple simpler ways to do this than the ones we'll be doing it today. But the motive of the video is to explain to you how Lambda functions came, how we used to do things before, and not really the most best way or coding wise the best way to do it. We'll get there, but for now the goal is to learn Lambda functions using this example. So yeah, I just wanted to keep that in context. So let's come here, let's create a package called model and let's create a class called product here, right? Okay, so we have this class called product. Okay, anyway, it doesn't matter. Let's refactor it to, okay, anyway, let's refactor it to Lambda package itself. Did it get refactored? It should have. Okay, so it's a new package in itself. Got it. So yeah, we don't need this any longer. Let's delete it. Yeah, we have this class called product and it has multiple fields. So Yeah, just for explanation, I have Lombok in here. Okay, for people not aware with Lombok, it's nothing but a library that helps us generate getters, setters, constructors, and so on. So it's a very helpful library. If you want to make me a if you want me to make a video on this, let me know. I'll do it. So yeah, so first thing we have is a private string product ID, right? And private string product name, private string product description, and private double product price. Again, just as a naming convention, you need not specify product. That doesn't convey anything better because the class itself is product. So it can be ID, name, description, and price. That would be a better way to do it. But since I've written it, let's just continue with that. Right now we can have setters here. Okay, let's directly get a data annotation that covers setters, getters in itself. Right, and as far as I know, it covers constructor also. So yeah, it covers the required args constructor what we want. Yeah, so if this is covered, we do not need to provide a constructor annotation also. Right, now let's create a main class and first create a data source thing kind of. Right, so for example, we can have this method called public static list of product get products, and we will be returning the products. Right, now let's quickly create some products. So it would be better if I provided a builder annotation. So builder annotation is okay, so this kind of provides the builder pattern implementation for this particular class. We like later I'll be making a series on, hopefully making a series on design patterns, and we'll cover builder pattern there. So yeah, let's create some products. Right, so product one and product dot builder dot, okay, yeah, product ID, product name, product price, product description, and product. I think that's all. Yeah, so let's create around, what do you say, 10 products. I know I could have used a loop and did some things, but yeah, just for simplicity's sake and not to make the code too complex for the beginners, I'll simply do this. Right, and okay, so product ID, right, one. If you are watching this video, please feel free to skip it by a minute or so. Right, okay, so just for time's sake, because we are anyway sorting on product price, I won't be providing product name because it doesn't help us a lot. Same applies for description. Let's quickly check that. Okay, it will take more time to do this than doing this. Okay, so product 3, product 4, product 5, product 6, product 7, product 8, product 9, and finally product 10. Cool. Now coming to the price, so this is 100, this is 50. Please note that it's not in a sorted order as to how I am providing. 2000, 1000, 200, 300, 1100, 1200, and 150. Right, okay, so it expects it to be a double. Let's change it to integer for now. So this will be sorted then. Yeah, cool. So then all you need to do is return arrays dot as list and specify all the products. Now I think I should have used a loop itself and generated a random value, but I think that's okay. We can do it sometime later. Product 5, product 6, product 7, product 8, product 9, and product 10. Cool. So we have this. Now let's look as to how we used to do things before. Right. So if you were given a requirement, so let's look at it a very, very realistic way, right? So you are building a web app, right? And there is a filter to fetch the data sorted by price. And let's assume that for now you're doing it in the backend itself, right? For certain applications, it might be good to sort the data in front end, but yeah, for this we are doing it in the, so anytime someone applies a filter, we make a call to the backend. A call comes to the backend, we fetch the products from the DB. Or again, there might be cases when you are applying the sort condition according to price in the DB query itself. But let's assume you're doing it at the application layer. You fetch the products from DB. In our case, we get the products like list products, so get products. We got the products. Now, how do you sort it? Initially, how you used to sort it was, there is this collections.sort method we have available in Java, and we used to provide a comparator here. Now, a comparator, okay, let's not cram it. Let's see as to what a comparator is. So if you see now, this is the functional interface. We'll come to this later as to how it helps, right? So this is a comparator, right? So it has just one abstract method, right? And that abstract method basically compare abstract method. All it does is it compares two things, and based on the value, it determines whether it's greater, smaller, and this is something that we implement, correct? So let's quickly see. So as I just typed a new comparator, this got auto completed, and based on how I want to sort, I have to return. So let's consider it as ascending only. So I'll do o1.getPrice dot compare to. So this compare to is now integer comparison. So that is obviously implemented, right? So we simply return this. Now this is fine. Now if I try to print it, right? So again, we'll see a good example right here. So how we usually used to print it is, what we'll do is, for product of product in products, we will do system.out.println a product, right? Now, important part, we need to give a I hope toString is there in this data annotation itself. Let's see. So yeah, toString is already there. So if we print, the product will be printed, right? Let's do this. So sysout, okay, sorry, somehow it doesn't work in IntelliJ. Println after sorting, and let's do it before sorting. Before sorting, let's see how things look. Okay, so before sorting, we had it in the order we gave, 150, 400, and so on. After sorting, we got it in the order we expected, 50, 100, 150. Now, if you were to ask a question, how do I do it? How do I do it for reverse order? Nothing. All you need to do is, let's compare it otherwise. So it will return the values accordingly. And if I run this, it will be sorted in descending order. Now this looks good. This solves a problem. But is it readable? Yeah, it existed. It kind of is. But again, I'm not a big fan of having such big code for just sorting it, right? what else can we do? Let's see. Comes lambda expressions. So initially, while with Java, functions were something that were not passed as like variables. Things have changed now. With lambda expression, you can kind of pass functions as variables itself. How? So we want to sort this. We have products. Now, because this comparator is the functional interface and it accepts this method, we can directly specify the implementation here. How? For example, let's take two things. Product, yeah, product 1, product 2, because this is what it expects, right? And this is how basically you can say a kind of a symbol for that. And now what if we return the same thing we did, O2, O1, sorry, in this case again product 1. Okay, sure. So yeah, not really. What if we returned product 1 dot get product price dot compare to product 2 dot get product price? Does this somehow look better than this? For sure it does. Now if you look closely, we are not doing anything different. We are overriding this method itself. The reason we are able to do it is this comparator is a functional interface, and when you provide this method, internally this method is overridden. The implementation for this method is provided basically, and that is why it's able to sort it. So isn't this much cleaner than this? Again, now instead of doing, now let's comment it. And again, how can we simplify this part? How about this? Let's do a products for each. And now just instead of iterating and things like that and printing, let's just do this, and we'll be able to print it. So effectively our code reduced to this. Now let's see as to why. Okay, yeah, sure. So let's try running it, and we see it works as expected, how we expected it to work. It is sorted in ascending order. Now if we want it to be in descending order, all you need to do is do it for product 2 first, and so on. You're aware of that. Now, is there a better way to do this than this? For sure, yes. But goal was to help you understand how lambda expressions help, how we are able to pass code as functions basically, and yeah, just simplify our code for that matter. Now coming on to the simplified version of this, it would look something like this. So we have the comparator interface. All we need to do is we just need to pass the product and the particular method that we have, and that will do the job for this. So for sure this is the best way to do it, but my point was to help you understand how lambda expressions are helping us. Yeah, production code, please do this. Cool. So with that in context, let's look a little bit more around how exactly lambda expressions help and how much they can be simplified, right? So I told you we have this this functional interface called as function. Okay, let's see, it's there now. So it has this method called apply. So okay, what it does now, again, an important task. So it takes certain argument, returns something, So it does some kind of processing for now, you can expect. This is up to you. It's just a interface, or this is just an abstract method, right? So let's say that we are given a task of doing some manipulation over a number, right? And yeah, obviously there are very simple ways to do it. We don't need a function interface and so on for that, but just for our understanding, right? So let's comment the print this stuff and come back to the main thing now. Okay, so let's discuss what our task is. Our task is to add 10 to a number, multiply it by 100, and then divided by 2, and then return it. These three operations we have to do. So this is nothing but manipulations on a number, right? Now again, this ideal case for this would not be to use a function interface, lambdas, and so on, but we are keeping it quite simple just for our understanding. Let's have it as a function. So we are working over integers, so let's keep it over the integer itself, and in this we don't care about the precision. We'll write it for now. We don't care about precision for now. Correct. So we have this add 10 is the first one. Now what does this accept? If we go to this basically we want an implementation for this. Again, one way is to implement the interface, initialize the class here and so on. Not needed. It need not be that complex. You can do this. It will be like this. But okay, let's do it this way first, so that you will understand as to, you know, how important lambda expressions, or how they solve the problem. So first what you can do is we can do integer plus 10. We can return it, right? Okay, and the second task was multiply by 100. Cool. So all we need to do is multiply by 100, and then whatever the integer you got, you multiply it by 100. And the third task was we had this integer and we divide by 2, and the new function we have, we return integer by 2. I told again we don't care about the precision for now. Now if you want to apply these operations, it's nothing complex, right? So yeah, we have this thing called as chaining is there. You can so once you specify various operations or function or the implementations for the function interfaces, it will do it one after the other. So it will create a composite thing out of it, and then you multiply by 10, and then you divide by 2, and you apply it on which integer. Say suppose I apply it on 10. Let's calculate it beforehand. So if I do 10 plus 10, that will be 20. If I multiply it by 10, it will be 2000, and if I divide it by 2, it should be 1000. So I should be getting the result as 1000, right? So let's just print it itself. So system.out.println, print this. Let's see what happens. What we expected. But this if my terminal was open, this doesn't even fit properly on the screen, right? So do you really want to do this? No, because it's a functional interface. There is just one function that we need to provide the implementation for. How about this? We take the number and we say return number plus 10. Okay, because you're not specifying the braces. How about we do this? Or like what I was trying to do initially was this, if you got confused. even this works, right? Similarly, we can change this, and why not just copy this, paste it, copy this, paste it. This will be multiplied by this, and this will be divided by 2. This works. This will solve your problem. Let's see if it does. Okay, so we are adding. Okay, give me a. Okay, we will multiplying by 100. Okay, add 10, multiply by 100. 10 plus 10, 20. Okay, so 20 star. Okay, so this should be 100. Yeah, sorry, my bad. Yeah, this will be 100, and let's run it now. It will print 1000. Yes, but again, this, I don't like this also. I know it reduced quite a lot in length, but I still don't like it. How? Because it's a single statement. We don't need this braces in the return statement. We can just be like number plus 10. Same applies for this. We can just be like number star 100, and same applies for this. We can just be like number by 2, and this will solve, even this will solve our problem. So things got reduced to 4 lines now. If you run this, it'll give the exact same output. Now again, because it's a single parameter, we don't even need this braces. So all you need is this, and you are done. So we reduced those huge line of code that was almost fitting the screen to these 4 lines of code, and our problem was solved. That is the power of Lambda expressions and how they help us. After this, I'll have a next video on Java streams. It'll be way more clear as to why Lambda expressions are needed and how they help once you see the video in streams also. But I hope that you have got basic clarity around why do we need Lambda functions in the first place. Now, I went like very roughly over predicate, supplier, consumer. I didn't actually went it, I just showed you that certain classes exist and nothing else. So so function, I showed you the use case, right? So you have this particular method that you need to implement, and you can implement just using a Lambda function right here. Now let's go over the 3. That is a supplier. I'm just writing it down so that I can do a control click. There is this thing called as a predicate, and there is this thing called as a consumer. Now what's a supplier? So suppose you want to return any value, any kind of value for that matter, you can just have the supplier interface. How exactly will you implement it? So it's very simple. You can have a supplier, this thing. So it's a supplier, and it obviously doesn't take anything and returns you 10. That's it. You can return anything. It can return a test string and so on. So this will be a supplier. So this is a good to have if you just need some kind of value, right? Let's come to predicate. This is very helpful when you have certain filters. So for example, you have certain value, and based on that you want to return, right? So predicate, say, is odd, right? Now how do you do this? So you get a value that is a number, and okay, again, as I told, I don't need this. So that is a number, and what you're trying to do is you return true if number mod 2 is not equal to 0, else you return, okay, my bad, I'm so sorry, is not equal to 0, you return true, else you return false. So if it's not equal to 0, it's true. And then what's wrong here? Cannot be applied to this. Okay, cool. So how about, I think we need to provide it here. So we provide the type and just we can return it. So now this is odd can be used to filter. I'll just give you a quick example. How do we do it? For example, you have a list of numbers. So let's say list integer numbers and then arrays dot as list 1 2 3 4 5 6 7 8 9 and 10, and you want to filter it, right? You want to just print the odd number of elements. So all you need to do is number.stream.filter, and what is the filter now? It expects a predicate, as you can see, that returns a true or a falsy value, right? So predicate our predicate name is odd, and then we just do a for each, we do system.out println, right? So let's see as to what we are printing now. We have commented what we don't need, and let's see. We should just get the odd values 1 3 5 7 9. So you understand as to how having this like this is just good to have provided in Java. So how do they exactly help? Suppose you have two values, you have something called as a by predicate already available. In this case, we did not need to specify this. In Java, there is something called as int predicate already there. So int predicate is specifically for integer value. If you look at the predicate, it is a generic one and you need to specify the type. So in our particular use case, int predicate works, right? Yeah, so because this expects this, you can specify, or you can like kind of typecast it, and this will work. Let's see how it works. Okay, so cannot be cast to java.url. Oh, my bad. Yeah, sorry. So yes, in predicate it cannot be cast to that. So you need to provide the predicate itself, and yeah, then you need to provide the type, that will be an integer and is odd. So this works seamlessly. That is obvious that it won't work. I didn't look at what this expects. So it expects a predicate itself and int predicate. Yes. So yeah, that was expected. Cool. So this is about how various existing functional interfaces in Java help. That may be predicates or suppliers I told you about. Consumers. I think consumers is left. So let's look at what a consumer is. So consumer is nothing but it accepts something, and you can do some manipulations if you want. So for example, if you have some object and you want to change something, you can have a consumer, and based on that you can do some manipulations, right? So that is about these in nutshell around various functional interfaces that exist in Java. Cool. Now comes the last topic around variable scoping in Lambda expressions. So okay, so I have had some notes. Let's quickly go through them. Like I prepared these to give you an intro around how they help. So default methods, we talked about what they are. They help us provide implementation in the interfaces without breaking existing functionality, right? Static methods, again, you're very clear with it as to why we need static methods. And again, coming to us to lambdas, we got a taste of lambdas. How they're solving a problem. We gave the comparator example and how our code was simplified a lot. Then yeah, let's drum rolls please. Let's come to the official definition, right? So a lambda function is nothing but an anonymous function. You can see we gave no names here to these functions, right? When we were passing it in, there was no name as such. So these are anonymous functions with no name and identifier. We can pass it to other methods as parameters, and hence function programming in Java, right? So we understood how it works. We talked about predicates, we talked about suppliers, consumers, functions which we used for our examples around this manipulation we were doing on an integer, and then final point